Peace be upon you and God's mercy and blessings. God willing, in this video, we will talk about something very important, which is how to create CID files in the releases available at the station, whether they are the bay control units or the protection releases. The basic idea here is that I have something called CID files, which are essentially the responsibility of the automation engineer in charge of the SAS system at the station. It is the automation engineer who creates the CID files, but sometimes as a protection engineer, I am required to create the CID files myself and then hand them over to the automation engineer. But if we are talking about what is correct or what is better for you, the best option for me is, of course, for him to do it. This is so he can adjust and then start to fine-tune and customize it, and then he can proceed to export it and implement it in the system, in his own system. And then he can proceed to export it and hand it over to be implemented in the system. Consequently, the same person who completed their work on the protection relay or on the bay control unit also worked on the CID file. This ensures that no one else works on that relay except him, which guarantees better quality of work. First, before we talk about the CID file and how to fix it, let's understand what a substation automation system is. What is a substation automation system? The idea is quite simple. In a substation, we have a set of buildings or rooms, like the switchgear GS and the control room, which contains the control panels and the protection panels. Okay, let's take an example. In the GIS, each bay in the GIS corresponds to a control panel inside the control room. What does each control panel contain, or what is it used for? Each control panel contains the single line diagram specific to the panel itself, and it shows you whether it's a double bus single breaker, 1.5 scheme, double bus double breaker, or any other type. It illustrates all the components present in the bay, from disconnectors or isolator switches, RS switches, in addition to, and it would tell you where your feeder is going or where your bay is going. For example, is it going to an overhead line, underground cable, transformer, static bar, compensator, or whatever? The important thing is that it would show you the single line diagram specific to your bay. Now, was it just a single line diagram? Of course not. Each of these components had an indication lamp next to it, allowing you to know whether the component is closed or open. Or not? Very nice. You also had something called the annunciator, and its purpose was your alarm system, where you could start seeing a set of alarms related to the GS. For example, the gas alarm, whether it was low stage or high stage, the DC circuit supervision, or something like an overload on the motor of the circuit breaker, for instance, incomplete, or the alarm between the disconnector or the earthing switches and so on. I also had something called the power meter, which would read the values of voltages, currents, frequency, power factor, active and reactive power, apparent power, and so on. This was, of course, through the current and voltage transformers present in the GIS. So now I have talked about all the things I could take from the GIS and send to the control panel, whether I was talking about statuses, alarms, measurements, and so on. But is this the only benefit of the control panel that I used it for? No, of course not. The second thing it was used for is control, which is evident from its name. How did I use it for control? Of course, after I compiled and gathered everything together, I could now look at the entire station from just one place. I could take readings and see everything from one location. This allowed me to perform operations more efficiently and to be able to see the entire station during operations safely and to be away from the energized area instead of being at the station or near the breaker or in a short circuit or any problem whatsoever. So I would be away from the energized area. This was the idea of the control panel located in the control room. Of course. Now, regarding the substation automation system, the substation automation system is an alternative to the control panels. What did I say? I said I would save myself the space that I would use for installing the control panels, save the cost of the control panels with the components inside them, and save on the cables extending between the GIS building and the control panels. I will use something else to be able to provide all of this, which is IEDs, intelligent electronic devices. Therefore, the intelligent electronic devices will take the place of the control panels, but in a slightly different way. We will understand what this means. These intelligent electronic devices take the place of the control panels, But in what way? In a slightly different way, and we will understand what this means. Now you have the IEDs, a collection of relays. I have something like the switchgear in the protection relay protecting the switchgear panel or the switchgear feeder. How about using it? In control as PCPU, the bay control and protection unit. For GIS, nothing. Install it for GIS. If you use it with bay control and call it bay control, you are repeatedly using bay control. Control, you are using bay control. You are using bay control. Or using it in the control, and I will call it the control unit, which is a unit that controls the cells you have. I told him, great, okay, so now, what is the status of my IED or my relay? The idea is quite simple. Instead of having cables extending from the JS building or from any place to the control room, now I have saved all these cables and made all these wires go from the panel to the relay located in the same panel of mine. Which are related to what? They are related to alarms, statuses, and indications, in addition to the readings of voltages and currents. And of course, I extract them with the story that will come, whether I'm talking about sequence components, frequency, power factor, power measurements, everything is fine, right? And I can also, through the PCU or the control unit, perform control, meaning I can give a set of commands. Great, very nice. So I placed the IED in each panel and started to take all the alarms and statuses from it. This way, I can draw a single line diagram on the screen of each of these relays or IEDs, and I can start to see my single line diagram. I can begin to perform control, read or take current and voltage readings, get indication status, or receive alarms. It doesn't matter to me. Everything I did in the control panel, I can now do here in the relay. But now all these relays are distributed or each one is separate. So, what's the solution now? The solution is quite simple. I will bring a set of panels, and these panels will contain switches. I will start connecting the fiber cables between my IEDs and these switches. Then there is a set of switches located here or in this place. Of course, it's not these panels themselves that I'm pointing to, but panels that contain a set of switches like the ones you see, such as rugged COM switches and others. After that, I start connecting them to the industrial PCs, through which I begin to connect your screens that are present here. And through these screens, you can see all the single line diagrams, because now you are communicating with all these IEDs. You start drawing all the single line diagrams as they were drawn on the control panels. You can see all the measurements, view all the alarms, and you can also issue commands to NEP or any panel present in your switchgear or GIS. How? By sending this command from your computer to the relay, and then from the relay to your field devices or field components, which include circuit breakers, disconnector switches, and so on. Great, so in simple terms, the substation automation system is essentially a replacement for your control panels. It can provide control, automation, and monitoring, and it has communication capabilities. Ultimately, this allows me to achieve a comprehensive substation control and monitoring solution as an alternative to control panels.